going from standard form to vertex form today. So you guys had seen how to complete the square to get it to the vertex form, which is pretty similar. So we're gonna take a look here at this. You should be on your quiz. I think the 3C's and 3M's are on quiz number 3, and 3U, you're on number 4. So this is the 3U work package. It's very similar to the 3M and 3C today. I'm gonna get there eventually, so you guys would have all seen this by now. Okay, so just to recall, we have our standard form of a quadratic, so that's in the form of ax squared plus bx plus c. And then our factored form, which is f of x equals ax minus s, x minus t. So we have our new form that we're going to look at, and we did look at that either on Friday or Monday, depending on the group. I can't remember which day for what. And so it would be in that similar form where the vertex is located at HK. So everybody should know that. That's not necessarily new. So since we can get so much information about a parabola from the vertex form, it would be useful to be able to convert from factored or standard to that vertex form. The reason why it's a lot easier is because we know our vertex, and then our A here, we're going to see a little bit more of that as the week goes on. Our A is going to tell us how like wide or skinny that U shape or that smiley face is going to look like. Yes, so the A value is the same in standard form vertex and factored form. It is not the same if the equation is the form a bx minus s. So if there's a number in front of the x's in here for our factored form. So one method to do is to use our zeros to convert from factored to vertex form. So determine the vertex of y equals 2x plus 4x minus 6, then rewrite it in the equation vertex form. So we saw either last week or earlier today that our vertex or axis of symmetry is found by using those two zeros. Okay, keep in mind that when we're using the S and the T, we're going to use the opposite signs that are in that bracket. So you need to make sure that you're putting the opposite sign, otherwise you're not going to get the right axis of symmetry. So our S is going to be -4 because it's a plus in here. And we're going to do plus, and because it's -6 there, it's going to be +6, and then divide by 2. So that gives us 2 over 2, which is ultimately 1. Okay, so that is our H value. I should be changing colors to do this for you guys. So this is our H inside of that vertex form. From there, what we do is we take our X. So X is equal to 1, and we're going to replace it. So replace in our equation. Okay, so we're going to go back to our equation, and we're going to replace X by 1. So we have 2, there's an X, so we're going to replace it by 1. Okay, and that leaves us with 2 times 5 times -5, which is -50. Okay, and that, I know it says that it's our Y, but in terms of our vertex, that's our K value. Okay, so that means that our vertex is the point, and we've seen this before, is the point 1, -50, where this is our H and this is our K. Okay, so our vertex form without any numbers at all is y is equal to a x minus h squared and then plus k. So that's why if we find our vertex, it helps us a lot because it puts us right into our vertex form. So it's nice and easy. And then like it said above, our A is going to stay the same because there's no number in front of these X's. So our A value is going to be 2. It's not going to change. Okay. So our vertex form is going to be 2 x minus 1 squared minus 50. So I find that one's relatively easier just because you don't have to do any factoring or anything like that. You don't have to complete the square. You literally just find your vertex and then you put it into the equation. So it's nice and easy for you. Okay, so I'm going to clear that and we're going to go to method number 2. So the first one was to use our zeros. The second one is to go from our standard form to our factored form. That way we can get the vertex, and that way we can put it into the vertex form. Okay, so our first thing that we're going to do, and this goes back to like the very first day, is we're going to look for a common factor. Okay, so this one has a common factor of 3. So this guy can be factored like so. Okay, this part, and there's some of you that done this or did this during their quiz or their assignment. So don't forget that, like, that's not the end. If you can factor what's inside the bracket, give her. So that would be a simple trinomial. So we need 2 numbers that multiply to give us -3 and add to give us -2. Okay, so -3, we would have, sorry, I'm having, we would have -3 and +1. I was having a little brain fart there. Okay, so this would be equal to x minus 3, x plus 1. Okay, same thing that we did above. So this is our s, this is our t. We're going to put it into our s plus t divided by 2 to find our h value of our vertex. So we've got, so remember opposite signs. So 3 plus -1 divided by 2. So that'll be 2 over 2, which is 1, just like our first example. Then you take this value. So this is our h value. We're going to put that inside of our equation. I'm going to use the factored form because I find it a little bit easier. Okay, so you're going to replace x with 1 inside of our equation to find our k value. So 1 minus 3, 1 plus 1. Getting kind of low here on my tablet. So 1 minus 3 is -2, and then +2, which gives us -12. So that means that our vertex is at 1, -12. So this is our h value, our k value. And like we did previously, okay, so our a value is going to be 3 right here. X minus 1 squared minus 12. Okay, so I'm going to clear that, and we're going to look at the third method, which is completing the square, sorry, which we had done either Friday or yesterday. So clearing. Okay, so this is where you can't necessarily have a common factor. You can't simplify a trinomial or simple trinomial. So you're kind of looking at this, and I know the 3 U's are more inclined, or the 3 M's are more inclined to use the complex trinomials. Don't do it for this case. This isn't what we're trying to do. Okay, so we are gonna use our drawing here. So what we're going to do is we can common factor the first 2 terms. And the reason why we're doing that is because we're adding a different c at the end, right? So we remember that we had used our b value, and you did divide by 2 squared, and you added that number inside the bracket and subtracted it outside here. Okay, so in this case, we have 4 divided by 2, which is 2, and then squared, which is 4. Okay, so inside of our bracket, we're going to have 2x squared plus 4x plus 4 plus 7 minus 4. Okay, so here, like I'm saying, there's a common factor there. So you can common factor the 2 out of there, and that's going to be our a value for vertex form. So you're going to be left with x plus 2, 2x plus 2, right? And then this will be plus 3. And then this is going to come up to x plus 1 squared plus 3. And there's your vertex form. Okay? So I'm going to clear this and we're going to look at some more examples. Well, one example. So for this one, find the equation of a parabola with zeros, -4 and 18, and an optimum value of 100. Okay, which is very nice because it gives us part of our vertex, because our vertex would be our positive or maximum or minimum point on our graph. Okay, so our x be -4 plus 18 divided by 2. So -4 plus 18 gives us 14 divided by 2, which is 7. So that means that our vertex is 100. So our h is 7, our k is 100. So y is equal to a, because we don't know a, 7. Oh, wow. We're going to undo that. There you go. That's better. Okay, so x minus 7 squared plus 100. Okay. And what you can do to find this a is you're going to use one of your zeros. Okay. So one of the zeros is -4, 0. Okay. So this is our x value. This is our y value. What you're going to do is you're going to go back here and replace your x with the -4, your y with the 0, and you're going to solve for a, which will get a little bit tricky if you haven't done that in a while, unfortunately. Okay, so just remember BEDMAS, where it's bracket, exponent, division, multiplication, addition, subtraction. So you're doing it the opposite way, okay? So is there anything being subtracted? We're going to simplify this a little bit more before we do that. So -4 and -7 is negative, okay? So is there anything being added or subtracted onto this one side? So there is, so we can get rid of this 100. And to get rid of that, we do the opposite operation. So right now it's being added. We're going to subtract it on both sides. Whatever you do on one side, you have to do to the other. Okay. You're left with that. We can also simplify this. So -11 squared is actually 121. Pretty proud of myself at the top of my head there for a second. Okay, and this is being multiplied. So the opposite operation of multiplication is to divide, and that cancels this guy out. Okay. So our a value is equal to -100 over 121. So on this guy where these the a, this would be -100 over 121, which is quite a wonky number if you ask me. So I'm going to clear this. You guys are going to do some practice questions. Hopefully that makes sense. I know this last little bit got a little confusing there for a second. But yeah, let me know.